Good evening, everyone. I hope I am audible to all of you.
Yes, very much. And good evening to you, sir.
Yes, yes. I will start at 6:30. Okay, I will wait for another 4 minutes time. Then I'll start.
Okay, no problem. Yes.
Madhumita Dasgupta, madam, are you there?
And I was joined from 6:15 itself. I was my net was actually disturbed a bit. So
Okay, no issue, no issue. Okay, we will start the
yes,
program.
sir, we will be starting at 6:30, right? Or sir
Yes.
will be starting to speak at 6:30. So
Okay,
I'll be
okay,
introducing, and then sir
okay,
can just
okay,
take
okay,
over
no
the
issue.
session. Yeah.
So, good evening to all of you.
Good
It's six.
evening.
Just okay, and today we are this is the day 3 of our 1 week online faculty development program on research methodology and data analysis. And today we have two respected resource person, CA Anandraj Shaha and Dr. Sujay Kumar Dhar. I think both of this session you will enjoy. So now I request Madhumita Dasgupta madam to take charge of this of both of these sessions. Okay, please, madam.
Yes, sir. Thank you. Good evening, everyone. A very, very warm welcome to all the people and all the respected professors and all our students and all our colleagues who have joined the session. I extend all my thanks to all those people who have taken the pain of joining the session. The first session will be conducted by C. Anandaraj Sahaswar, and he is an assistant professor in Department of Commerce, University of Calcutta, Kolkata, since July 2018. 2018. And before joining the university, he served as an assistant professor, Department of Commerce, Horingata Mahavidyalaya. He's an associate member of ICAI. He's an MCom from University of Calcutta and securing first class first position and an MPhil from the same university. The University of Calcutta awarded him with gold medals and President of India medal for general proficiency. He's almost 12 years of teaching experience in undergraduate and postgraduate levels. His research interests include corporate sustainability, CR, and co-integration of stock markets. He has already published many research articles in journals of international repute. We will be delighted and we are looking forward to a wonderful session from Sir. Sir, over to you. We are waiting for your session.
Thank you, moderator ma'am. I hope I'm audible to all of you.
Yes, sir, you are audible.
So I express an out of my deep sense of gratitude to the president of this association, and also I would like to thank the honorable secretary of this association, Pema Lama sir, and I also uh, express my gratitude to the organizing secretary, Dr. Vijit Kundu sir, and those who are respected teachers present here. Now, my today's topic is descriptive statistics and inferential statistics for data analysis purpose. The topic is too large, and I initially thought the time would be more. I will get more time, but since I have been allotted 1 hour, then I extended it to 1.5 hours. So I try to show you first descriptive statistics. Then, if time permits, I will show you the inferential statistics, and I will show you some practical aspects of descriptive statistics as well. So let us start my screen first. I would like to share my screen. I hope my screen is now visible to all of you. Is it visible?
Yes, now it is visible.
I switch off my video uh, for your many of you may face the network problem. So today's topic is descriptive statistics and inferential statistics for data analysis. And before we start the idea about basic descriptive and inferential statistics, I need to give you some idea about the data or variables. Last day, I hope one resource person has partially covered this issue. And today I will tell you about various aspects of the data and measurement skill. Then I will give you different types of descriptive statistics measures available for these kinds of data. So before we start the descriptive statistics, we will give you some idea about variable. So it is actually characteristics of any population or sample figure. Uh, Basically, in statistics, it is denoted by capital X, capital Y, capital Z in this way. Say, for example, marks of any student in any paper. This may represent variable, and the possible values of the variables uh, is called possible observations of the variable is called values, and observed value of a variable is basically considered as data. So data can be of three types, many of you know: cross-section data, time series data, and panel data. So here my topic is not about time series, cross-section, and panel, but I will tell you how the data are measured in various scales, because these scales are important. Many a time we have seen that the students and the researchers face difficulty for applying different types of statistical measures. Uh, all statistical measures are not applicable for all kinds of data. It depends on the nature of the data. So before we start any statistical test, it is also very much required to have an understanding of data. Otherwise, the test may give the result, because computer will give you the result if you fed anything into the computer, but the results may not have any meaning. So it is better, before going into the detail of any statistical test, learn about the data and which data can be available for the test, this information is very much required. Now, according to the levels or scales of measurement of the data can be of two types mainly. One is categorical data or qualitative data. So qualitative data uh, may be of two types. One is nominal data, another is ordinal data. So categorical data or qualitative data, these are of two types. One is nominal data, that is level data, ordinal data, that is ordered data, that includes level plus order. And another type is numerical or quantitative data. So this can be of again two types. One is interval data, another is ratio data. Interval data and ratio data. We basically people, financial people or financial data to some extent ratio data. So what is categorical data? Uh, it cannot assume numeric value. It can be classified into two or more non-numeric category, but this categorical data can be converted into numerical figure depending on the situation. I'm giving the examples. These are only considered as level data. So categorical data have two types. One is nominal data. These are the discrete units. Discrete means you can count it. These are the label variables and have no quantitative values. And one of the important feature of nominal data is that it has no order. That means if you change the order, there will be no change in the meaning. Male and female, example. If you change the order, there will be no change in the meaning. The example I have already given, color of hair, gender, different locations, hair color, all these are basically nominal data. So it is countable, discrete data, but there is no order. Now, another type of categorical data is ordinal data. This has the feature of discrete plus order. Nominal data is not ordered, but this is discrete plus ordered data. So when ordering is there, but difference between two is not basically known. So difference between okay and unhappy cannot be assumed to be same as very happy and happy. So this difference cannot be defined. So various types of non-numeric data like customer satisfaction, discomfort, happiness, they fall in this category of ordinal data or ordinal variables. And in statistics, we generally convert or provide numbers in a Likert scale from 1 to 10 in order to measure this type of variables, and we collect data accordingly. My examples are educational level. It can be ordered from, say, for example, from pre-secondary, secondary, higher secondary. In this way, you can give the order also. So very happy you can give ranking 1, 2, 3, 4. In this way, you can order it. Now, numerical data or quantitative data is mostly used in many of the cases. So real numbers and hence quantitative or numericals. The ordered units have the same differences. But the problem is that here you will get the same difference ordered unit, but there is no true meaning of the zero. It can be added, it can be subtracted, but multiplication and division or calculation of ratio is not allowed. Say, for example, our Celsius. If I say the temperature is 0 degrees Celsius, that does not mean there is no existence of the temperature. Here, 0 itself has some feeling, and here in this case, there is don't have a true zero or absence of zero. So, in this scale, if I say temperature of Kolkata is 20 degrees Celsius and temperature of Delhi is 40 degrees Celsius, we can't say that Delhi is 22 times higher, hotter than the Kolkata. So multiplications and division is not allowed in interval data. Examples are Fahrenheit scale and Celsius scale temperatures. Ratio scale is basically called as ultimate nirvana. That means it includes all the characteristics of nominal, ordinal, and interval scale. So it has level, it has order, it has exact value between the units, and it has absolute zero also. So for this kind, ratio is widely used in statistics. They can be added, they can be subtracted, they can be multiplied, and it can also be divided. Example is height, width, length. So ratio data can be measured. So I've shown you. First is nominal data. Nominal data has only label. It has no order. Then ordinal data, it is label plus ordered variable. Interval data, label plus ordered variable plus proportionate interval in betweens. And ratio scale or ratio data, it includes all the features of nominal, interval, and ordinal. In addition to, it can accommodate an absolute zero figure. Now, keeping in view with this type of data or types of variables, four types of variables, we start discussing descriptive statistics. In each and every research, may it be based on population, may it be based on sample, it is desired to test the important features of the data because descriptive statistics most of the cases it becomes inevitable in case of population type of study, and in case of sample it helps to identify the nature of the data. So if your study is based on the sample, descriptive statistic will help you to understand the nature of the data, and it will help you to identify which tests are applicable for these types of data. So descriptive statistics, before I start, there are basically two broad subdivisions of the statistics. One is called descriptive statistics, another is called inferential statistics. I will try to, first of all, tell about descriptive statistics. It is basically describing, organizing, and summarizing data set for the sake of convenience in understanding. And when you will calculate the descriptive statistics about the data, it is something that you can make sense of the data or you can feel the data. You can understand what is the characteristics of the data. So before conducting any test or before going into the detail of very complicated test, it is basically desired or it is custom to test it, to test or to calculate the descriptive statistics of the data. Now it helps exploring and making conclusions about the data in order to make rational decisions. I already told you, in order to take different types of decisions, descriptive statistics is calculated about the data, and it is also important for sample and it is all important for population study as well. It tells us what happened in the past and use analytical methods. Different analytical techniques we will use. We'll tell you one by one. And different types of tables and graphs we prepare. In newspaper, we get different types of reports organized in a systematic way. So newspaper report presented in an organized manner, it also takes part of the descriptive statistics or gives an impression of the descriptive statistics. And before conducting any test, many a time we construct different types of graphs and different tables that help us to visualize the data. So that's why I told it helps to feel the data. Descriptive statistics also provide numerical descriptions. Numerical description is possible with numerical and quantitative variables. For qualitative variables, first we need to convert into some quantitative features, then we can calculate different types of statistics. Now, in case of descriptive statistics, we basically, when we talk about descriptive statistics, we have basically measures of position. which is commonly known as measures of central tendency. Many of you have already calculated, or many of you know that uh, three important measures of central tendency is a mean, median, and mode. Many a time we have seen that many researchers, many papers use this mean, median, and mode, but there are certain limitations, there are certain factors that need to be considered before calculating mean, median, mode, because in different types of data, different descriptive measures can be considered. Not that mean can be calculated in each type of data, median can be calculated in all types of data. So there are certain limitations of this descriptive measure. Now in descriptive statistics, we also the measure of spread. It is basically the known as measure of dispersion or measure of variability. There are few measures that is used in descriptive statistics. We frequently calculate all, and statistical softwares also help to calculate all these types of measures of position and measures of spread. And third important descriptive statistics that we basically uh, consider, that is measure of shape. So there are few descriptive statistics that are available, which helps to find out, or which helps to show the measure of shape of the data. So first I will talk about measure of position. Measure of position is basically talks about the central tendency, that is whether the data is actually centered or not. Many of you know that we basically calculate average of the observation or mean of the observations, but not only mean, in descriptive statistics, in the central tendency, measurement of the central tendency, there are other descriptive measures available, which is median and mode. So first let us come to mean. It is basically the average of the observations. It is basically average of the observations. X bar, if I say this is the sample mean, if X bar is the sample mean, you will get summation of X divided by N. Summation of X divided by N. And mu is the population mean. Mu is the population mean. So by calculating X bar of sample mean, or by calculating population mean, you can get the average of the observations. Now there are different ways by which you can calculate sample mean or population mean. Uh, Different types of data need different types of formula to be used. Simple formula is available for frequency distributions, and this is assumed method. And this is the sample mean and population mean as shown. In case of sample, we use basically small n, and in case of population, it is divided by capital N. And now another important measure is called median. It is that value lies in the middle after ranking all scores. That means if you rank the data set either ascending or descending order, the data or value that remains at the middle is basically known as median. Now, how the median is computed? In case of odd n, that means if the number of observation is odd, then median is n plus 1th divided by 2 observations. And if that is even, you will get an average figure. So I have already shown you how median is calculated by simple data. You can see this is odd. So in case of odd number, this is the median, which is the data set lies at the middle of the set after ranking them all. But in case of even data, the median will lie at the middle point. So it will be 5.5 here. Now it is very simple statistics mode, but these statistics will help you at the time of calculating descriptive statistics, or it will give you different idea, and where you can calculate mean, where you can calculate median. That is very important to know. Many people just feed the data in the computer, and computer gives result, without knowing the real factor or real matter, basically we compute different types of statistics. But it may so happen that that statistic is not applicable for that type of data. So it is very important to know which descriptive measure is available for which type of data. And in case of mode, it is most frequently occurring scope. That means the value which occurs with higher frequency is called basically mode. So there are formula for calculating mode. In this example, you have seen that 5 is only the number which occurs 3 times. 1, 2, 3. So here modal value is equals to 5. So mode is basically applicable in case of uh, ordinal data, or uh, in case of the first category of the data, that is nominal data. So mode is very important in those categories of data. But basically, we generally avoid the mode in ratio types of data. So comparisons of different types of measures. In case of our descriptive statistics, uh, interpretation means mean is the center of gravity. And if the data are quantitative and frequency distribution is roughly symmetric, not exactly symmetric. In that case, it will be better to use mean for interpreting data. Median, if the data is arranged in ascending order, then it divides the data into two parts, 50% and 50%. And this is also available when data are quantitative and frequency distribution is skewed. That means not non-symmetric. And in case of mode are basically uh, the most frequent observation. That means observation which occurs with highest frequency. This is basically called mode. And in case of mode, which basically when the data are qualitative nature, basically we use the most frequent observation, that is mode, as a measure of descriptive statistics. Now I have already shown you different scales of measurement on the basis of which variables are categorized as nominal, ordinal, and ratio scale. So I will be telling you which descriptive measures are available for nominal data. So for nominal kinds of data, basically they are level data without any order. So you can compute frequency table, you can compute proportion, you can compute percentage, and for more than two categories, you can also compute frequency table, percentage, and mode. I told that mode is basically applied in case of nominal data without any order. So mode is very important in case of nominal data. Otherwise, nominal data is shown using different types of frequency table, using calculating the percentages, calculating the proportions, and we use basically pie charts for showing these types of statistics or data having nominal data. Now, in case of ordinal data, since it has order, so you can compute rank order. You can calculate median also, because you can order it. So median will be considered as the middlemost value. So there are other statistics that you can compute on the basis of this: frequency distribution, mode, range you can calculate, and uh, non-parametric statistical tests are available for this kind of data. Now, interval data. Interval data is having equal distance in between. So you can calculate arithmetic mean, that means AM, and other descriptive measures are available like frequency distribution, mode, median, range, standard deviations. And in this case, you can calculate parametric test. You can take the parametric test like t test, like z test, as inferential statistics. So within descriptive statistics, you can use frequency distribution, mode, median, mean, range, and within inferential statistics, you can use parametric test like Z test, like T test, etc. So in case of ratio data, ratio variable, you can calculate mean and variance. So most of the tests you can conduct based on ratio data, and this is also based on parametric test. You can use any types of Z test or T test, including ANOVA and linear regression test. Now, the most important question is which measure is the most appropriate? Which measure is most appropriate among mean, median, mode? It depends on the situation. It depends on the types of data. I told you at the very beginning, we basically do not study the data and we use the different types of descriptive measures without knowing which measures are applicable for this data or not. So before calculating descriptive statistics, it is important to have understanding or to have knowledge about what measures are not applicable, or if the data types are different, then we can calculate different types of descriptive measures. Say, for example, mean is very prone to extreme values. I will show how the mean is very prone to extreme value. So mean can be applied when the data have no extreme values. Since mean are very much influenced by the extreme values, so if the data have no extreme value, then we can use mean. Median, the data can have extreme value because median is the middlemost value if you arrange in ascending order. So if we have extreme values, then there will be no problem because middle value will not be having extreme value, and there are no big gaps in the middle of the data. So this is one of the important point. Mode, data have many repeated numbers. If the data have repeated numbers, then we can utilize mode. Otherwise, if the data does not or data do not repeat for multiple times, for 2 times or 3 times, in that case you will not get any mode will be not applicable. So if you have repetition in the data, then you can apply mode, otherwise there will be no scope of using mode. Now I'm giving you one data set. It's appropriately taken average lifespan of various animals, and it is given in years. You can see there are 6 observations. These 6 observations. We have we have 7 observations. We have 7 observations. One is 35 years, another is 30 years, 50 years, 200 years, 30 years, 70 years, and 20 years. So we have 7 observations, and these observations are obviously one of the observation is basically not very helpful or unlike. I'll be showing you. Now, first of all, the question arises, is there any outlier in the data set? Outlier, is there any outlier in the data set? That means out of these 7 observations, is there any outlier? Another important question is that outlier is the 200, because all the data sets, this is falling in the very distant way. So 200 as compared to 35, 30, 50, 70, 20, this is more. 200 will lie in a very distant way. So it is considered to be the outliers. Now, another important question is that which animal do you think lives for 200 years? This is another important question. So if the data set is like this, or if your data set is like this, then choosing the appropriate measure, I would like to show you the data set again. 30, 35, 35, 30, 50, 200. This is, I told this is the outlier. And if I calculate mean, median, mode with outlier, I am getting mean 62. Without outlier, I am getting mean 39. So you can see mean is influenced by the outlier. Mean is influenced by the outlier, means mean is prone to the extreme values. So effect means there is increase in the value 23. So mean changes too much. Without outlier, it is 39. With outlier, 62. So mean changes up to 23. Now median, it is the middlemost value if you arrange the data. So in case of median, Without outlier, it is coming 32.5. With outlier, it is coming 35. So there is a difference between 2.5 and median changes very little. Now regarding mode, 30, 30. Mode is 30, 30. Why mode is 30, 30? Because here 30 appears two times. So that's why mode is 30 without outlier and 30 with outlier. So there is no change because mode is only with two repeated numbers. So mode means number which occurs with highest frequency. So 30 occurs with highest frequency. But in case of existence of the outlier, mode is 30. Existence of the outlier, without existence of the outlier, mode is also 30. Now the question is, which measure is the best for this type of data set? I've already provided you 7 observations, out of which one observation is extreme, that is 200 years, and no animal lives for 200 years. But this extreme observation, that means these outliers may occur due to human error, may occur due to the nature of the data set, or you may get this type of data set. But without reducing this outlier or without eliminating this outlier, if you calculate this type of descriptive statistics, then you will get this type of effect with mean, median, and mode. Now the question arises, where the great effect you have seen with outlier. We have seen that the mean is affected by the most for this existence of the outlier. So which is the best measure out of mean, median, mode in existence of the outlier? This is an important question. Now in case when there is outlier, median is the best for the data set. Median is the best because in case of mode, it occurs with two frequency. That means 30 occurs two times. So you will get only two repeated numbers. But if the 30 does not occur two times, then obviously there will be no mode, not applicable. But you have seen that in case of only median, it changes only 2.5. So for existence of the outlier, it has only effect 2.5. So median is the best for these kinds of data set. Now I would like to give you another important examples. You have seen that 10 observations are given, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you take 10, this plus this plus this plus all this summation x divided by 10, that means n, you will get a mean of 5.5. Obviously, you will get median of also 5.5. Now, if I multiply the extreme value with 2 without changing the entire data set remains same except the 10th data set, that is 10th observation, that is 20. 10 multiplied by 2, 20. In that case, you see that extreme values, mean is influenced by the extreme value 6.5, but the median is not influenced by the extreme value. In case we again change it, we again multiply the 10th data observation. That means if I multiply 10th observation into 10 times, I am getting 100. And because of the existence of the outliers 100, I am getting mean 14.5. Mean is changing. Although the data set remains same except the 10th observation, I am changing, and median in all the cases remains same. So mean is very much influenced by the outliers or extreme data set. So if your data set have extreme values, then if you compute mean, then mean will not give you proper interpretation. In that case, it is better to take median as measure of descriptive statistics. You have seen that I have already taken extreme values. So in this case, mean is the most frequently used, but it is sensitive to extreme score. Now let us talk about measures of dispersions or measures of variability. You know, in case of measures of variability, we basically central tendency indicate the value of a variable which is average or central or typical in a data set, and measures of dispersion indicate how the data are spread around the center. So if the data are spread around the mean, then it is basically the characteristics of the normal distribution. But if the data are spread out from the center, that means the mean, then the data set will have a high value of variability. So I'll show you variability. It is the extent to which the scores in the distributions differ from each other are spread out. You can see that in this case, in three samples, sample A, sample B, sample C, the mean value remains same. Mean value 6, mean value 6, mean value 6. But if you look at the observations, one observation 0, another is 2, another is 6, 10, 12. 0, 2, 6, 10, 12. In all the cases, if you calculate mean, you will get 6. But the observation are scattered. So variability increases because it is not close to mean. This is the data close to mean, but all data are other data are not close to mean. But in case of sample B, you can see that mean value is 6 and the data are scattered around the mean. So you can see the data lies around the mean. And in case of this one, sample number C, all data lies within the mean, that means 6. So here variability is no existence of variability. It is highly variable data. It is highly variable data. It is moderately variable data. So if the data scattered from the mean at extreme level, so variability increases. Now I am showing you another important examples. Say for example, these are the share price of Wipro, Larsen and Toubro, and Satyam. You can see in all the cases, the mean of the share price will give you the equal value, that is 80 rupees, 80, 80, 80. Now in this case, question arises in which company you would invest because mean of the share prices are giving the same results. So in this case, we will invite the measures of dispersion to explain the variability of the observations because mean as a measure of descriptive statistic is not fulfilling the requirement because all the observations are having the same amount of mean, that is 80, 80, 80. So we are not in a position to take any decisions about in which company we would like to invest based on the mean as a measure of descriptive statistics. So in this case, you can see the observations are not equally lying. So I would like to calculate different types of measures of dispersions, mainly index of qualitative variations, range or interquartile range, standard deviation, and coefficient of variation. We mainly use, and statistical softwares basically give you the data, give you the information about standard deviation and coefficient of variations. But measures of dispersion first comes to index of qualitative variations, IQV. It is basically applied or it is applicable when the variable is the nominal variable. It shows that that data is distributed between different categories or different attributes. So the formula is this one. I'll show you what is the examples. Here, categories are given: services, operations, administrations, and other. And we require P square. So this is the percentage square value. We require 4250, and IQV is calculated 76%, and its range is from 0 to 1. If the index of qualitative variations, if the value is 0, that means all the values fall in the same category. When it comes to 0, IQV value is 0. That means all the values of the data set fall in the same category. When IQV is equal to 1, that means values are equally distributed among the categories. And If IQV value is in between, then you have to interpret accordingly. So if IQV value is 0, that means all the values fall in the same category. If it is 1, that means values are equally distributed amongst the category. And if the values are in between to 0 to 1, then interpretation should be accordingly. So IQV as a descriptive measure is used when the variable is basically normal. Now range, many a time we use range. Statistical softwares also give uh, values like range. When you feed different types of data, you will get the results called range. And it is basically the difference between highest value minus lowest value. So data with highest value minus data with lowest value, you will get the range. But this is basically not applied when the complicated nature of study, or you will apply range with little or no knowledge of statistics. When the data is very simple type of data, then you can apply range. Otherwise, for complicated types of data, if you apply range, then obviously interpretation or meaning of the data will not be very helpful. Now I am showing you different types of data. So it can have same range, because 1 1 1 1 9. So 9 minus 1, highest value is 9, lowest value is 1. 9 minus 1, it gives you 8. But if you change the data set, in this case also, highest value is 9, lowest value is 1. So 9 minus 1, you will get the different, not the different data, the range, but the same range. In both the cases, you will get 8 as range, but you can see the data set are completely different. So as a result, range as a measure of dispersion, it is used for a very crude measure of dispersion. Now quartiles, the quartiles actually divides the entire data set into 4 equal parts. So it is also very much helpful when in your data there exist outliers. So Q2 is the median because it is the middlemost of the data. Q1 is the median of the data below Q2, and Q3 is the median of the data above Q2, and we will calculate the interquartile range. Interquartile range is used as a measure of variability. Interquartile range is basically used as a measure of variability because it divides data into 4 parts. So each part having 25%. Each part contains 25% of data, and interquartile range is basically given by Q3 minus Q1, that is third quartile minus first quartile. And this type of interquartile range IQ are basically calculated when the data is not normally distributed. We use interquartile range when the data is suffering from various outliers problem, so that we can avoid outliers, and so that we can take this third quartile minus first quartile into the data set. We basically calculate interquartile range. Now, one of the most important measure of dispersion and widely used measure uh, has several and numerous applications in statistics, that is called standard deviation. How far each number in a data set is far from their mean. So standard deviation, it is calculated. Standard deviation is calculated x minus x bar whole square whole divided by n. But this is a very simple form of standard deviation. But for sample and for population standard deviation, it will change. So for population standard deviation, how it is calculated, and sample, it is calculated in this way. I already show you how sample standard deviation is calculated. If you have the average depth of the river, and if you know the depth of the river at different points of the of the land, then you can calculate standard deviation, and it comes to 3.5 feet. In this way, we basically calculate standard deviation as a measure of dispersion, but you can see one important features of measure of standard deviation. In this three data set, data A, data B, and data C, you are having several observations, and in all the data set A, B, C, you have same mean 15.5, 15.5. But if you look visually, you can see the data sets variability are not the same. Here the variability is towards the mean, or they are not so scattered. And in this case, the data is very much scattered, and it is highly scattered data. No data is around the mean. So as a result, standard deviation is 3.38. Higher the standard deviation, higher is the variability, or vice versa. The interpretation is like this. If your standard deviation is high, that means variability is high, and standard deviation is often considered as a measure of risk. That means if the standard deviation is high, that means risk is high, or vice versa. So in this case, the standard deviation is high means the variability is high as compared to this, and this case also variability is high as compared to the data set B. So standard deviation as a measure of variability is widely used. So you can see that mean as a measure of central tendency is not fulfilling its duty or is unable to interpret the data. But if you use the standard deviation, you can understand how the data are variables, or it shows the variability of the data. Now, another important measure is the coefficient of variation. Standard deviation is basically an absolute measure. It is not free from unit. But coefficient of variation, CV, is another important measure of dispersion. It is free from unit, so it is a relative measure. If the comparable data sets having the same unit of measurement, then you can use standard deviation. I can repeat, if the comparable unit having the same unit of measurement, then you can use standard deviation. Otherwise, say for example, if one figure is given in rupees, another figure is given in dollar, another figure is given in pound, and if these data sets coming from rupees, coming from dollar, and coming from pound, if you calculate standard deviation, obviously if you calculate, you can calculate. If you use the computer will give you the data, computer will give you the information, but this standard deviation cannot be calculated. This is not comparable. If you give this numerical figure to the computer, or if you himself calculate it, then obviously we'll get the standard deviation, but they are not comparable because the unit is not same in the three kinds of data. So when the data sets are not having the same kind of unit, so in that case, it is not a very good measure. Although standard deviation is widely used, but it is an absolute measure, not the relative measure. But in case when we are having different kinds of units in a different data sets, it is possible, or uh, it is required to calculate the coefficient of variation. Coefficient of variation is calculated as standard deviation divided by mean into 100. Since it is ratio, you can easily see that standard deviation by mean into 100, that means risk per unit of mean. Coefficient of variation is basically risk per unit of mean, per unit of mean. So it is ratio. If you multiply with 100, then you will get a percentage form. Higher the coefficient of variation, higher is the risk, and vice versa. So if in this kinds of data set, you can see, I'm giving you an example. Security A, security B, security C. The mean value is 167.1. Mean value for security B is 1530.2, and for security C, mean value is 17.3. But if you look at the security, say for example, these are the price of the security A, price of the security B, and price of the security C. For the time being, you can assume that all these figures are represented in rupees. So one in rupees, another in rupees, another in also rupees. So in all the cases, you can see that highest average or highest mean is given by security B. Obviously, when you will get highest average, that means price is highest or amount is 1530.2. Obviously, you would like to invest in security B, but if the security B is the investment objective, in that case, standard deviation is also high due to the high amount of mean. But you can see that coefficient of variation, if you calculate, it gives you 12.8, which is the lowest among all these three. So, which coefficient of variation is minimum? In this case, we would obviously like to invest in security B because price is also very high. So price as compared to price, if you take comparison of the price and if you have sufficient fund, there is no problem. But if you do not have sufficient fund, obviously you would try to invest in these kinds of security having minimum 117.3. But in this case, coefficient of variation of security B, it is the least. So one should purchase this one with low amount of coefficient of variation. So coefficient of variation as a measure of dispersion, it is widely used when the data sets or comparable data sets are not having the same unit of measurement. I've already told it. If it is in rupees, if it is in US dollar, and if it is measured in pound, then obviously they are not comparable. And if you can calculate standard deviation 41, 195.1, and 5.9, they are also not comparable. But if you take coefficient of variation or if you calculate the coefficient of variation, they are comparable because we have converted it into a ratio data and it is free of unit of measurement because it is a relative measure. So in this case, you calculate the coefficient of variation and it gives you the ultimate results. Now you'd like to compare it. Range is the difference between highest score minus lowest score, and it is basically a crude measure. We rarely use range, although the statistical softwares give you the uh, answer of the range. Standard deviation, 68% data fall within the one standard deviation of the mean. If you draw the standard normal curve, around 68% of the data will fall under the standard normal curve within the area plus minus 1. So it is also helpful when you have numerical data and the data is approximately symmetrical or normal. And interquartile range, it is basically considered when the data is ordinal type and data is numerical type and data are highly skewed. In case of skewed distributions, in order to eliminate the outliers, many a times we use interquartile range as a measure of variability. Now we have already told you measure of dispersion, measure of central tendency. The measure of shapes are another important descriptive statistics, and within measure of shape, if the data is symmetrical, then we may use mean or median to measure the central tendency as they are almost equal. But if the data is skewed, then the median will be appropriate to measure the central tendency. And within the measure of shape, we have two kinds of measure. One is widely used skewness, another is kurtosis. Now, skewness, it describes whether the data is distributed symmetrically along the mean. That means whether the data is around the mean or data is scattered from the mean. It is basically told by skewness. A skewness value of 0 indicates perfect symmetry. A negative value implies left skewed data. This is the negative skewness, left skewed data. And positive skewness implies it is right skewed data. So you get the most of the tail towards right hand side, and in this case, left skewed data, the tail is towards left hand side. That's why it is left skewed data and right skewed data. But in case of symmetric distribution, that means in case of data following normal distribution, you will get a complete bell-shaped curve. And in this type of distribution, your mean will be equals to median equals to mode in case of symmetric or non-skewed distributions. Here, excess kurtosis will be equals to 0. But in case of positively skewed, mean, median, and mode will not be equal. And in case of negatively skewed, you can also see mean, median, and mode is not equal. But if the data or variable is following normal distribution, in that case, we will get the mean equals to median equals to mode. Now, kurtosis is all about the degree of flatness or steepness of the shapes. And you have three types of kurtosis. One is called platykurtic, another is called mesokurtic, another is called leptokurtic. So when you have leptokurtic, that means kurtosis value is greater than 3. In case of leptokurtic, kurtosis value is greater than 3. In case of data following normal distribution, kurtosis value is exactly 3. So this kinds of case, in this case of mesokurtic, kurtosis value is exactly 3. And in this case, platykurtic, kurtosis value is less than 3. Kurtosis value is less than 3. So many a time you require to test the normality. In the next session also you'll have some important idea about normality. So by comparing the kurtosis value and by comparing different types of statistics, you can also come to conclusions that your data is following normal distribution or not. So in this case, there is excess kurtosis positive. There is positive excess kurtosis. In this case, there is no excess kurtosis. Excess kurtosis is 0. And in this case, there is negative excess kurtosis, or excess kurtosis is negative. In these three types of steps, basically we will get this type of data. When you will run the different types of curves, you will get this type of results. Now, by this, I complete this descriptive statistics, most of the central tendency measures of dispersion and measures of shapes. Another important is the measures of strength of a relationship. And many of you know that it is basically given by correlation coefficient. So it actually shows the strength of the association. And it is basically the linear association between two variables, say for example, x, y. So it can take values or range within -1 to +1. It cannot be more than that. So correlation coefficient values must lie within -1 to +1. So higher, the larger correlation in absolute term. Larger correlation in absolute term means stronger association without following the negative or positive sign. You only consider the amount, that is the 77% or 80%. Larger the association, larger the value in absolute term means stronger the correlations. Basically, we follow three, or we calculate different types of correlation coefficient. In case of ordinal data, we follow the Spearman, or we calculate Spearman rank correlation or row correlation, because rank correlation, if the data can be ordered or data can have order, in that case we can use non-parametric correlation test, that is Spearman rank correlation test or row correlation test. If the data is ordinal, you can also calculate Kendall's rank or Kendall's tau correlation test. If the data is parametric, that means if the data is interval and ratio data, we basically calculate the Karl-Pearson's product moment correlation, which is the most popular correlation test, Karl-Pearson's product moment correlation. If the data is numerical data, that means quantitative data, in that case we basically calculate Karl-Pearson's correlations. Now, different types of correlations. In the cases mental impairment and live events, correlation is 37, and in this case negative correlation is 56. That means inverse relationship, negative correlation. When GDP and fertility, if one increases, another decreases, so correlation is in inverse, and there is a moderate correlations. But in case of GDP and percentage using internet, correlation is 0.89. So correlation value is very high. Even if it is minus 0.89, it would also be considered as very high without considering the sign. So if it is minus 18.89, that means 89%, or only 89, in both the cases, the correlation will be considered to be the high if we compare these three values. Now, in different types of correlation coefficient from -1 to +1, you will have this type of data scattered through. So, in case of Pearson's correlation coefficient, so these are the different types of correlation coefficient you will get. So, thank you for the first part. I will show you the several uh, tests. I hope now regarding descriptive statistics, I have a data set of macroeconomic data. This is the data set which is downloaded from World Development Indicator. Can you see my data set? Is it visible to all of you?
Yes, it is not visible.
Yes. Now it is not visible. It's visible. Okay.
It is now visible.
Okay. Now you can see this is the data set uh, downloaded from World Development Indicator. This is India's data from 1988 to 2012. Data is very old, but we can calculate different types of descriptive statistics. And many of you know how to calculate, and many students are there, I know. So for beginners, this will be very much helpful. Otherwise, now this data you can see there are high ranges of data. Say for example, this is market capitalization data of listed company, and this is represented in current US dollars. This is foreign direct investment data. This is gross national investment. This is gross capital formation, real interest rate. Out of this 1, 2, 3, 4, 5, 6, out of these six variables, four variables are represented in US dollar. These two are not represented in US dollar. This is one in percentage form. And trade openness is basically difference between export minus import and adjusted by gross domestic product GDP. So it is the difference between export and import adjusted by gross domestic product. And this data set you can see. So in this type of data set, uh, there will be high frequency in the data. So better you convert it into a logarithmic form. And I have already converted into logarithmic form. You have seen that. Data, if I convert in natural log, I will get this type of figure. I have already converted. This is LM cap, logarithm of market capitalization, LFDI, logarithm value of log of FDI, log of gross national income, log of gross capital formation, and these two figure is already ratio figure. So there is no requirement to log it. Otherwise, there'll be problem. So in case of ratio figure, we generally do not take logarithm. Other figures are converted into log. If I draw the graph or if you calculate graph, it will have no meaning because the figure is too close. So in this type of test, we can calculate descriptive statistics, or you can calculate descriptive statistic taking the full data as well, or you can take calculate descriptive statistic taking the log data. First of all, say for example, I am calculating descriptive statistic taking the full data set. That means without logging. Now in Excel, it is basically not loaded. If you go to the data, you will not get any measures like this, but it is not loaded. So you have to install it. Many of you know, many of you have installed. So for this purpose, you go to the file. Then in file, you have options. You go to the options. Then you can see in options, there are so many tabs available. Out of these, you have add-ins. Now, in adding features, you will get analysis toolpath. Analysis toolpath VBA. I am taking analysis toolpath. And here I would like to go. And if you press go, then it will get analysis toolpath VBA. So I am giving check mark of analysis toolpath. And if I say OK, then you will see one particular features is added by the Excel that is called data analysis. This is not pre-installed. You have to install it by going into the add-in features of the Excel. So if you click this data analysis, then there are so many statistical tests which you can perform here using this analysis data analysis toolpack. And out of these so many features, you can calculate descriptive statistics, you can calculate correlation. So let us calculate descriptive statistics. How is it calculated? First you show the input range. My input range without taking year, because year is not variable. I am taking variable like this from market capitalization to trade openness. I am taking this figure. I have already taken. Obviously, label in the first row. Yes, I have label in the first row. All these are label of the variables. So I am checking it. I am giving a check mark of it. Now, output range. If you want to get output in a particular area, we can show the area. Otherwise, if you want to get output in a new workbook, then I would click new workbook. I require summary statistics. I require summary statistics. I click OK. Now, after clicking OK, you will get a new file. This one, like this. You can see that this is created by the Excel software. And for your analysis purpose, what you need to do is that you have to organize it for the purpose of your research. So if you organize it in this way, you can take it. So let me do something here. So all these are not required because given the same mean median mode, you can see. So I'm deleting these particular rows. Now you can see in this case, mode is not applicable because no observation occurs for more than one time. So as a result, if the observation or observations do not occur with more than one frequency, then obviously you will not get any mode, because mode is the observation occurring with the highest frequency. So in this case, your mode value is not applicable. So, but other figures are very high. So therefore, these values are very complicated. So you may not be able to explain this type of. That's why I tried to take the logarithmic figure. That means these figures are highly scattered. So therefore, one figure is rupees, another figure in percentage. So therefore, I converted into log figures so they become comparable to some extent, natural logarithm. Now I am performing the same test with descriptive statistics. I am showing it is automatically, it has taken summary statistics. Now it has given some important concept. If I now if you delete all this, it is not required. I hope we have few minutes time. So in this way, you can calculate which mean is the better mean, because you can see that in case of this one, real interest rate, sorry, which mean is the greater mean, you can see in this case, LGNI is having the highest mean 27 as compared to other. Median value, range value is given, and kurtosis value in most of the cases is not equals to 3. Negative, positive is there. So there means the data is not following normal distribution. If you calculate Jhargram statistics, then you can understand that the data is not following normal distribution. because kurtosis value in most of the cases is not near to 3. So in all the cases, it is negative, obviously. Standard deviation is 1.29, 1.91. So standard deviation is highest in case of this one. So standard deviation is highest in case of trade openness. So the trade openness figure is more risky here. The variability is the uh, highest in case of trade openness. And you have maximum value and minimum value, and counted means there are 25 observations. So this way you can calculate. Now same figure can also be used for calculating the correlation coefficient. I'm using data statistics. Now I'm taking correlation coefficient, new worksheets, input range already taken. I'm taking, sorry, level in first row. I have to mention it. Now correlation coefficient is calculated. Trade openness, real interest rate. So if I write real interest rate, this is, and this is trade openness, I can show how these figures are calculated. Okay. So this value ln cap with ln cap, so obviously association cannot be found, but the correlation between LFDI and LM cap, it is 92%, highly correlated. Correlation with market capitalization and gross national income, it is 94%, highly correlated. But correlation with market capitalization and real interest rate, that is negatively correlated, moderate correlations. So you will get this type of correlations figure if you calculate correlation, but this figure is suffering from one important aspect. I have calculated correlations, but this correlation is not matchable because this correlation is of the sample. Whether this correlation can be tested on the basis of population, so we require to test the correlation, but this feature is not available in our Excel. So in order to test this type of correlation, you have to use different types of softwares which can give you the idea of different types of testing methodology. Say for example, I will show you how different testing formula is given. Say for example, in this case, I am using eViews for calculating the correlation, and the same descriptive statistics can also be calculated. I can open data. I hope you can see the data as a group. I have taken different types of data called logarithm of FDI, logarithm of gross capital formation, logarithm of gross national income, market capitalization, real interest rate. Obviously, this is not logarithm, natural log. This is trade openness is also not logarithmic figure. So from data set from 1988 to 2012, I have taken. This is the old data, but it will serve our purpose. Now, if you want to calculate descriptive statistics using eViews as a software, now if you go to the view, and if you have descriptive statistics, you have common sample or individual sample. I will calculate descriptive statistics on individual sample. Now you can see highest mean value was found in case of gross national income. Highest mean value. It was found. Mode, it was omitted from this because mode is having not applicable value. So therefore, observation is not repeated. Median, you can see standard deviation is highest in case of real interest rate. Standard deviation is 2.36. Variability is very high. Kurtosis value is none of the kurtosis value is near to okay, this is 3, so it is near 3. This is also near 3. This is near 3, and if you report the Jarkivera statistics, Jarkivera statistics says that the variables follow the normal distribution because null hypothesis is accepted because the probability value of the Jhargram statistic is more than 5%, so it is accepted. Null is accepted, therefore, uh, although kurtosis in this case 2.19, so it is near to 3. That's why it is accepted. So Jhargram statistic is uh, based on the kurtosis and skewness value, and observation figure is already given. Now you can also calculate correlation, but in this case, one important feature is there, which is not available in case of which is not available in case of our Excel. That is, you can calculate correlation with the probability value, which will take into consideration your sample figure. Because if you calculate correlation based on your sample, that does not mean that on population this is accepted. So in order to take real decision, you require to estimate the based on population figure. So you require to calculate correlation together with probability value, and I am calculating this. Now you can see in this case I am getting the correlation statistics, and the value beneath each and every figure, this is the correlation figure, this is the probability figure is given. Although in case of LFDI and LGCF, correlation is 89%, so it's a very high association. LM cap, LFDI, there is high association, it is also 94, and in all the cases, result is significant. So the null hypothesis of existence of no correlation is rejected at 1% level of significance because the value is 0.000 probability value. It is less than 5%, so null is rejected at 1% level of significance. Only in this case, RIR and LFDI, the association is inversely correlated and the association is not very good. It is less than 50%. So in this case, null hypothesis of no correlation is rejected at 10% level of significance because it is greater than 5%. So you may accept it at 5% or you may reject it at 10%. So in this case, your correlation figure is reported with probability value, and it is better when you report the correlation figure, always calculate the probability value. This feature is not available in Excel. This feature is available in our reviews and in other available softwares. So I hope I am able to make you understand about this one. Other part is descriptive statistic, but time is very limited, so I am not able. So any time is allowed extra. It is near to 7:50. Am I audible?
You can take another 10 minutes.
I can take 10 minutes. Okay. I will show very shortly the inferential statistics without going into the detail of different types of. I will show you the different measures of inferential statistics. Uh, so, in case of inferential statistics, it is very used when you are working on the sample, not on the population figure. So I am skipping all this, what is called inferential statistics. That this is the most important figure. Those who are the beginners in data analysis or research methodology, they must know this figure because in most of the cases, if you work on the sample, we try to predict population based on the sample. So our population parameter, that is population mean, population variance, all these will remain unknown in most of the cases. Sometimes it is not possible to calculate population parameter. Sometimes due to time and cost constraint, it is also not possible. We generally try to calculate descriptive statistics always, but sometimes calculation of descriptive statistics or for calculation of population parameter is not possible. Say, for example, in our blood test, if we want to have our hemoglobin rate, whether it is 12%, whether it is less than 12%, it is not possible to calculate our exact hemoglobin test. Because if we require to calculate the exact hemoglobin test or hemoglobin rate in our blood, obviously our entire blood must be squeezed out from the body. Then you have to test. So population study sometimes is not possible. So in some cases, we are bound to follow the sample statistic because of this figure. In case of blood test, it is very much important to have sample instead of population. So unknown population, for knowing the unknown population, we generally select a random sample and obviously following the statistical procedures, and we basically calculate the sample statistic. Parameter is related to population and statistic is related to sample. So as we cannot calculate the population parameter, in order to predict or in order to take decision about population parameter, we are drawing random sample, and on the basis of random sample we are calculating the sample statistic, and on the basis of sample statistic using probability theory or confidence limit, we are taking decisions about population parameter. So how it is done? This is actually done by means of inferential statistics. This is the main important part of the uh, inferential statistics. I'm skipping this. What? There are basically two important difference of population and parameters and sample statistic. Notations and notations will basically use the Greek and Roman notations, but in case of parameter, uh, it actually does not vary. Why parameter does not vary? Because of the fact that in case of parameter, it is actually one value. It takes the all sets of observation, but sample statistic, it is calculated from different sample size. So if your sample size is n1, you will get x1 bar. If your sample size is n2, you will get x2 bar. So for different sample size, you will get different sample statistic. So parameter does not vary, but the sample statistic varies based on the population, based on the sample size. And parameter, in this case, it is calculated no. Most of the cases, population parameter cannot be calculated. I told you that population parameter of our blood test, our hemoglobin rate, it is not possible to calculate for a person who is living. And so we are calculating the sample statistics. Now I'm skipping these slides. I'm skipping the hypothesis methodology as well. I just want to show you in case of data type, which test we'll be using, parametric and non-parametric. Now, basically, two types of inferential statistics are available. One is called parametric, another is called non-parametric. So we often use parametric means our popular tests like Z test and T test. So if the information about population is completely known by means of its parameter, then it is called parametric test. So if you have complete information about the population's parameter, that means you are drawing from one population and you know about the population information. So as a result, we can use parametric test. But in case of non-parametric test, if you do not have any knowledge about the population or the parameter that the population follows, in case we shall use the non-parametric test. Non-parametric test is called parameter-free test. So in this case, you are not required to assume that whether the variable follows normal distribution or whether the variable follows any particular distribution. But in case of non-parametric test, we basically do not require to take any assumptions about the population. So examples of non-parametric test is Mann-Whitney test, rank-sum test, Kruskal-Wallis test, and I would like to show you that different types of data. For nominal data, that means data of attributes like gender, like marital status, we shall use non-parametric test. In case of ordinal data, we shall use also non-parametric test. In case of interval data, like temperatures, like all these types of things, we generally use in parametric test. And in case of ratio data, like age, income, we shall use the parametric test. So it test also depends on the nature of the data. I'm skipping this. I would like to tell you different types of tests, these slides. Now, basically, parametric test, it is called metric test, and non-parametric test. One sample test. So for getting the idea about unknown population mean, unknown unknown population mean, we calculate basically T test or Z test. For two sample test, for independent sample, we can also consider t-test, z-test, and if for paired sample, we can consider paired t-test. This is very important. In case of non-parametric test, one sample or two sample. For a single sample test, we basically use non-parametric most important and famous test that is called chi-square test, KS test, or run test. And in case the sample more than two sample, but if you want to calculate or if you want to calculate the test about two samples, in that case you have this chi-square test, Mann-Whitney test, median test, and KS test. And in case of paired sample, you can test sign test. You can have sign test, Wilcoxon's ransom test, McNamara test, and chi-square test. So all these tests are available based on the parametric and non-parametric. An idea about whether your variable is following any distribution or your random variable is not following any distribution. So if you have an idea that your data is following any distribution, then obviously you can use parametric test. But when you do not have any idea about the probability distribution your variable is following, in that case, it is better to use non-parametric test. Now, hypothesis testing is basically test of association and test of differences. Basically, we calculate, uh, we take hypothesis testing in order to take decisions about means and proportions. And in case of differences, also we take this, we calculate or we conduct hypothesis testing based on means and proportion. And in case of most important parametric test, we basically use or we randomly use that is called Z test. So in case of Z test, it can be one-tailed, it can be two-tailed, depending on your alternative hypothesis. So if your null hypothesis, whether it is one-tail or two-tail, it does not depend on the null hypothesis. It depends on alternative hypothesis. So in this case, in case of this one, alternative is not equal to sign. So obviously it is two-tail test, and it is mu is greater than mu naught. So it is right tail test, and in this case it is left tail test. So in this way, different types of null and alternative will get. So this is basically followed in case of t test and z test, that is the parametric test. You see the z scale is given. Z scale is given for level of significance 2.5%. That means 5% level of significance Z test is given. Its critical value is given. I'm not showing due to time shortage. I'm not showing the practical aspects due to time shortage. This is right tail test, 5% level of significance. Critical value will lie at the right side of the standard normal curve. And in this case, you can see that 95% is the area under the standard normal curve. This is the non-shaded region, is the acceptance region, and shaded region is the rejection region. And this is left tail test. Critical region will lie at the left hand side. So these are the synopsis of the different types of tails of test. And basically, you just try to remember that whether it is right tail or left tail or both tail, it does not depend on the null hypothesis. It always depend on the alternative hypothesis, because it also helps to take your decisions about which critical value you take. In case of right tail test, in case of left tail test, you will get only one critical value. But in case of both tail test, your critical value, if it is 5% level of significance, you have to take critical value 2.5%, because critical value will lie both sides of the standard normal curve. So I have skipped it to some extent. Uh, this is the important table where if the size of the sample is greater than 30, then which test we shall follow. If the size of the sample is greater than 30 and population standard deviation is known, we shall follow Z test with Z distributions. And if the population standard deviation is not known, but size of the sample is greater than 30, we can also use the Z tail. Only in case the size of the sample is less than 30 and population standard deviation is unknown, we shall only follow students t distribution, t test. So this is most important rule for deciding which test among Z and T we shall follow based on the sample size. This is basically called as rule of thumb. So by this, I would like to conclude. I hope I am able to make you all understand about this topic. Uh, Although I can't show you the numerical or practical aspects relating to the inferential statistics. Anyway, Thank you for this session. If you have any question, you can ask me.
Thank you so much, sir, for the wonderful deliberation, and we were truly, enlightened with all the information and all the guidance that you have given us. If there are any questions, we can take that, and then we can move on to the next session.
Madhumita madam,
Yes, sir.
due to paucity of time, we cannot take the questions now. So
Okay.
if anyone of the among the participants have any question, they can post it in our WhatsApp group. So we'll send those questions to the resource persons. Okay.
Yes, sir. That then thank you so much, sir, for this wonderful session. And we all would like to thank each and everyone who was present in the current session, and you, of course. Our next session will be our next resource person is Dr. Shujoy Kumar Dhar, sir. He is a faculty member of ICFAI Business School, Kolkata. His core area of expertise is finance, economics, control. He has more than 16 years of teaching experience. He's obtained his doctoral degree of philosophy and uh, he and in commerce from Calcutta University. He has done MSc in economics with specialization in econometrics and statistics from University of Calcutta. He has done his MBA with finance specialization from SWM University of Calcutta. Professor Dhar is a member of Federation of Indian Professional Trainers. He has authored derivative books and several other books on banking sector, published by Vandana Publications. He has more than 65 research publications in different national and international reputed journals. He's also attended and presented research papers in different national and international seminars as well as conferences. Sir, we like to welcome you for the session. Thank you so much, sir. Over to you, sir.
Thank you so much, Madhumita madam, for your beautiful introduction. Thank you so much. So now I will present. So I hope screen is visible to all of you.
Yes, sir, it is visible.
Thank you so much, madam. Now, I will, good evening to all of you. This is Dr. Shujoy Kumar Dhar. I will discuss on normality test and its application on data analysis. I can understand all of you have your own busy schedule, and I'm really grateful that despite of your busy schedule, you are attending the session, even if at this late evening. So my humble submission to each one of the participants is, let's make the session more interactive. So you please ask me the questions. Whenever you have any doubt, you can unmute yourself and you can ask the questions. And also, if you want to chat, write in the chat box, you can do it. So, because without the interaction, our session cannot be fruitful. Am I audible to all of you?
Yes, sir, it is audible. Just to interrupt you,
Yeah.
Samarpita Mukherjee, madam, if you can mute your mic. Samarpita Mukherjee, madam, if you can mute your mic, some unnecessary noise is coming. Thank you very much. Okay, sir, please proceed.
Thank you so much. So today we'll discuss normality test and its application on data analysis. Now, instead of presenting the topic theoretically, I have decided to discuss my PhD thesis. With the help of that example, I'll be able to explain how and why normality test is very important. And on the basis of the outcome of normality test, we have to decide future course of action of our research. Now, if you see, my title of the thesis is a study of corporate governance practices in Indian banking sector. Once again, I repeat, a study of corporate governance practices in Indian banking sector. Now, let me start with the research gap. Whatever I have found after the literature survey of different existing articles, journals, that corporate governance policies in banks can be analyzed from two perspectives: shareholder perspective and stakeholder perspective. Shareholder perspective is all about financial governance, and non-financial governance is all about stakeholder-oriented approach. Now, several research articles are interpreting the financial governance practices of global as well as Indian banks. Evolutions of Basel guidelines have prioritized the risk management strategies of banks. But unfortunately, there is a dearth of research work which can provide a basic outline about both financial and non-financial governance practices followed by Indian banks. So, these are my objectives of the study: to analyze the evolution of corporate governance practices, to make a comparative study of some selected public and PSU, public and private sector banks, to analyze the impact of corporate governance practices on financial performance of banks, and to suggest appropriate measures for better implementation of corporate governance practices in Indian banking sector. Please feel free to ask your question in case you have any doubt. Am I clear to all of you? Anybody has any question?
Yes, sir. Please.
So, now my research methodology, which is very much important. We have taken all the banks which are listed in the BSE BankX, Bombay Stock Exchange BankX, as on 31st March 2016, on the basis of their free float market capitalization. And we have developed a corporate governance disclosure index. What is corporate governance disclosure index? It is total score of the individual bank divided by maximum possible score obtainable by bank. You can see in the screen that 5 PSU banks, Bank of Baroda, Bank of India, Canara Bank, Punjab National Bank, State Bank of India, and 7 private sector banks, Axis, Federal, HDFC, ICICI Bank, IndusInd, Kotak, and Yes Bank, had been considered for the study. I have developed, if you see, we have developed 18 hypotheses. Hypothesis 1, for the sake of simplicity, I will just focus on null hypothesis, because by default you can understand what is alternative hypothesis. Hypothesis 1 is there is no variation in performance between PSU and private banks. Hypothesis 2 is there is no difference in bank performance across years. We have taken 5 financial years. Hypothesis 3, there is no relationship among corporate governance disclosure index and average income of the bank. Hypothesis 4 is there is no relationship among corporate governance disclosure index and average local ownership. Hypothesis 5, there is no relationship among corporate governance disclosure index and average board size. Hypothesis 6, there is no relationship among corporate governance disclosure index and average board independence. Hypothesis 7 is there is no relationship among corporate governance disclosure index and average return on asset. Hypothesis 8, there is no relationship among corporate governance disclosure index and average net NPA. Hypothesis 9, there is no relationship among corporate governance disclosure index and average capital adequacy ratio. Hypothesis 10, there is no relationship among corporate governance disclosure index and average ROE. Hypothesis 11, there is no relationship among corporate governance disclosure index and average size of audit committee. Hypothesis 12, there is no relationship among corporate governance disclosure index and average EPS. Hypothesis 13, there is no relationship among corporate governance disclosure index and average number of board meeting. Hypothesis 14, there is no relationship among board size and bank performance. If you see first 13 hypotheses, we are trying to see the corporate governance practices of the banks, where from hypothesis 3 to 13, my dependent variable is corporate governance disclosure index, and independent variable is average income, average local ownership, average board size, average board independence, average return on asset, average net NPA, average capital adequacy ratio, average ROE, average audit committee size, average earning per share, and average number of board meetings. From hypothesis 14, we are trying to relate how corporate governance practice and financial performance of the banks are getting related. So if you see hypothesis 14, there is no relationship among board size and bank performance. Bank performance we have measured on the basis of 3 variables: return on equity, earning per share, and return on asset. So hypothesis 15, there is no relationship among board independence and bank performance. Hypothesis 16, there is no relationship among internal audit committee size and bank performance. Hypothesis 17, there is no relationship among capital adequacy ratio and bank performance. There is no relationship among number of board meetings and bank performance. So far it is hypothesis 18. Now, what are my research questions? What are the scopes and directions of corporate governance in Indian banking sector? How do corporate governance practices vary between PSU and private banks? Is there any interdependence between corporate governance practices and financial performance of the banks? Which are the appropriate measures for better implementation of corporate governance practices in Indian banking sector? Limitations of my study. The sample size is restricted. I've already told 5 public sector and 7 private sector banks, which are listed in the BankX BSE as on 31st March 2016. And the study is based on secondary data. Primary data are not being considered, because you can understand, since my study is corporate governance practices in Indian banking sector. So even if I develop a question here, I have to target board of directors, top management of the banks, whether it is executive directors, non-executive directors, independent directors. But you can understand it will be very difficult to get the data, because corporate governance, since it is the internal rules, regulations, code of practices of the banks, so it will be very difficult to get primary data. This is my plan of work, what I have done. Chapter 1, introduction, including brief review of available literature. Chapter 2, conceptual framework of the study. Chapter 3, regulatory framework for Indian banking sector. Chapter 4, a comparative study of some selected public and private sector banks. Chapter 5, empirical study, findings and interpretation. Chapter 6, suggestion and concluding observations. Now, actually, I have given a very basic outline of my thesis, because then I will be able to relate why normality test, according to me, is the most important foundation before we starting any quantitative research. My previous speaker has already mentioned, but at the cost of repetition, all of us, we know there are 2 types of tests. If I just broadly classify, parametric versus non-parametric test. Parametric test in a layman language, by the nomenclature, I hope all of you will be able to understand. Parametric test is a test in which parameters are assumed, parameters are given, and the population distribution is always known. To calculate the central tendency, a mean value is used. And these tests are very common. This makes performing research pretty straightforward without consuming much time. Examples of parametric tests are Z-test, T-test, etc. No assumptions are made in the non-parametric test, in contrary, as it measures with the help of the median value. Few examples of non-parametric tests are Kruskal-Wallis, Mann-Whitney, and so forth. Now, what's the difference between Mann-Whitney and Kruskal-Wallis? Mann-Whitney test is used to examine whether two samples are from the same population or not. Kruskal-Wallis test is used for comparing two or more independent samples of equal or different sample sizes. So, in other words, Kruskal-Wallis extends the Mann-Whitney test, which is used for comparing only two groups. So Mann-Whitney test is used for comparing two groups. Kruskal-Wallis can be used for comparing multiple groups. But purpose of the test is same, whether the samples are belonging from the same population. Now, I have already told you that. Now let me quickly come to my empirical study. Because first three chapters, more or less, it is literature survey, theoretical aspect, theoretical construct, regulatory framework. So ultimately, let me go to my empirical research. This corporate governance disclosure index has been calculated by after taking into consideration 14 financials and 13 non-financial disclosure of the bank for a period of 5 years. So each bank is awarded a score of 1 if the bank appears to have disclosed the concerned issue in the annual report, and 0 otherwise. And I have already told you that corporate governance disclosure score or disclosure index have been taken as dependent variable, which is measurement of the corporate governance practice of the banks. And independent variables have been taken from the literatures. Total income, local ownership. What is local ownership? That is any ownership except the foreign ownership. So local ownership incorporates government ownership. It incorporates domestic private ownership as well. Board size. What is the board size? How many directors are there in the board? Independent directors. How many independent directors in the board? Because board independence is very much crucial. Return on asset, net non-performing asset, capital adequacy ratio, return on equity, internal audit committee size, earnings per share, number of board meetings. Now, first, I have started with normality test. My null hypothesis is data is following normal distribution. Obviously, alternative hypothesis is data is not following normal distribution. So, Shapiro-Wilk normality tests have been conducted. If you see, I have told you 12 banks we have considered for the study for 5 years. So, 60 annual reports of the banks have been analyzed. And that's why, if you see, degree of freedom is 60. Degree of freedom is 60. Now, if you look, all the variables except board size and capital adequacy ratio are significant. Why significant? Because p-value is less than 0.01%. So null hypothesis is rejected. Data is not following normal distribution. And whenever data is not following normal distribution, these data cannot be used for so-called z-test, t-test, Pearson correlation coefficient, regression, multiple regression, ANOVA, etc. So, just if you recall, when I have discussed that when data is not following the normal distribution, we have to go for non-parametric test. So, I have to go for non-parametric test. If you see hypothesis 1, there is no variation in performance between PSU and private banks. We have conducted Mann-Whitney test. Anybody, can you tell me why I have taken Mann-Whitney test? Why not Kruskal-Wallis? Anybody? If you answer. Abhishek, Alak, Amrita, Anandaraj sir, Anjali, Anjana, I'm taking first name, Archita, Arpita, anybody. It will be better if the session gets interactive. Dr. Amit Majumdar, Gaurav, anybody? Madhumita madam, Mau, Pallavi, anybody wants to answer? Anybody wants to write in the chat box? See, we have taken Mann-Whitney test because normality test has been failed. So normality test has been failed. I've just shown you. I have conducted the Shapiro-Wilk normality test and alternative hypothesis has been accepted, that is data is not following normal distribution. When data is not following normal distribution, I have to go for non-parametric test. And when hypothesis 1 is, I have to compare between PSU and private banks. That means there are two groups of data. And when I have to compare whether the two samples are belonging from the same population, we have to go for Mann-Whitney test. See, I've already told you in the background, Mann-Whitney test is used to examine whether two samples are from same population. So, after conducting the Mann-Whitney test, we have observed that all the variables are significant except EPS. So, alternative hypothesis is accepted. Performance of PSU and private banks vary at 5% level of significance. There is a variation in performance between PSU and private banks. Now, hypothesis 2. See, I've told you I have taken 5 years data. 11, 12, 12, 13, 13, 14, 14, 15, and 15, 16. So this time there is no, what is my hypothesis? There is no difference in bank performance across years. So now I have to, there are 5 samples. So once 5 samples have to compare, I cannot do Mann-Whitney test because Mann-Whitney test is used only for 2 samples. So for multiple samples, we have to use Kruskal-Wallis test. In Kruskal-Wallis test, if you look, all the variables are non-significant except EPS. That means null hypothesis is accepted. Performance of PSU and private banks don't vary across years. So from hypothesis 1, we come to know performance of PSU and private banks vary, but over the years, performance does not vary. Now, since it is normality test, After conducting normality test, it has been observed the data is not following normal distribution. So I cannot go for Pearson correlation. So what we have done, Spearman's rank correlation, where we have taken the correlation coefficient, obviously rank correlation coefficient. And if you see significant values, that is p values are also there. So correlation coefficient between corporate governance disclosure score and domestic ownership is significant. Correlation coefficient between corporate governance disclosure score and number of independence directors, significant. Correlation coefficient between corporate governance disclosure scores and ROA is significant. Capital adequacy ratio and corporate governance disclosure score, significant. Corporate governance disclosure score and number of members in audit committee, significant. Corporate governance disclosure score and average number of board meetings, significant. So, alternative hypothesis is accepted for domestic ownership, board size, board independence, return on asset, net NPA, capital adequacy ratio, audit committee size, earnings per share, number of board meetings in a year. Null hypothesis is accepted for average income and return on equity. Now, therefore, degree of association between corporate governance disclosure and domestic ownership in bank, corporate governance disclosure and board size in bank, corporate governance disclosure and number of independent directors in the board, corporate governance disclosure and return on asset, corporate governance disclosure and net NPA, corporate governance disclosure and capital adequacy ratio, corporate governance disclosure and number of members in audit committee, corporate governance disclosure and earnings per share, as well as corporate governance disclosure and number of board meetings in a year are significant at 5% level of significance. On the other hand, corporate governance disclosure index and average income and corporate governance disclosure index and return on equity. See once again, average income and corporate governance disclosure index. So here p-value is 0.545, much higher than 0.05 also. And corporate governance disclosure index of disclosure scores and ROE, p-value is 0.120, much higher than 0.05. But in other cases, it is either 0.05 or less than that. Now, I have taken the average of 5 years data. That means so far we have taken the data of 5 years, 2011, 12, 12, 13, 13, 14, 14, 15 and 15, 16. Now I have taken the average income, average domestic ownership of those 5 years. Average board size, average number of independent directors, average ROA, average net NPA, average capital adequacy ratio, average ROE, average number of members in audit committee, average earning per share, average number of board meetings. Again, I have conducted Shapiro-Wilk normality test. This time, if you see, all variables except total income and return on asset are non-significant. That means null hypothesis is accepted for remaining 10 variables. So data is following normal distribution now. So just try to understand, when I have tried to analyze the 5 years data individual, then my data was not following normal distribution. So I have to go for non-parametric test. That is Kruskal-Wallis test. That is Mann-Whitney test. That is Spearman's rank correlation. But once I'm calculating average of last 5 years, and then I'm getting, after conducting the Shapiro-Wilk normality test, now data is following normal distribution. Now I can use Pearson correlation. Now I can use multiple regression. So just try to understand. If I don't conduct the normality test, I'll never come to know whether my data is following normal distribution or not. And if my data is not following normal distribution, and if I conduct Pearson correlation, if I conduct multiple regression, if I conduct t-test, there will be no interpretation will come. Because in non-normal database, I cannot use parametric test. On the other hand, if it is non-normal database, then we have to go for non-parametric test only. Mann-Whitney, Kruskal-Wallis, Spearman rank correlation. But if my data is following normal distribution, then obviously we cannot go for non-parametric test. That is Mann-Whitney, Kruskal-Wallis, Spearman rank correlation. There we have to go for t-test, z-test, Pearson correlation, and multiple regression. Tell me, participants, up to this, anybody has any doubt? Is it clear why normality test is really important? Any doubt, please? You can unmute yourself, you can ask me the questions. So, now for hypothesis 3 to 13, see, now on the basis of this average data, I have calculated Pearson's correlation coefficient. And if you see, corporate governance disclosure index and average local ownership, their correlation is significant. P-value is less than 0.05. Corporate governance disclosure index and average independent board of directors, significant. P-value is less than 0.05. Corporate governance disclosure index and average return on asset, significant. P-value is less than 0.05. Corporate governance disclosure index and average net non-performing asset, significant. P-value is less than 0.05. Corporate governance disclosure index and average capital adequacy ratio, their correlation is significant. P-value is less than 0.05. Corporate governance disclosure index and average return on equity, significant because p-value is less than 0.05. Corporate governance disclosure index and average members of internal audit committee, significant because p-value is less than 0.05. But if you see corporate governance disclosure index and average income, they're insignificant. P-value is 0.328, more than 0.05. Similarly, if you look, corporate governance disclosure index and average board size, insignificant. P-value is more than 0.05. And corporate governance disclosure index and average earnings per share, P-value is more than 0.05. Am I clear? So, degree of association between corporate governance disclosure index and average domestic ownership in bank, corporate governance disclosure index and average number of independent directors in the board, corporate governance disclosure index and average return on asset, corporate governance disclosure index and average net NPA, corporate governance disclosure index and average capital adequacy ratio, corporate governance disclosure index and average return on equity, corporate governance disclosure index and average number of members in audit committee, corporate governance disclosure index and average number of board meetings are significant. And if you see, when I'm talking about corporate governance disclosure index and average local ownership, it is minus 0.633. That means if local ownership is more, somehow corporate governance practices is not that much efficient. Logic is very simple. Because if any company, including bank, if foreign investment amount is more, if qualified institutional buyers are investing more and more, by default, that means there is a positive sentiment about the foreign investors. And they will not make their investment unless and until they are 200% assured about the corporate governance practices. If you see corporate governance disclosure index and my average independent director, minus 0.676. That means just for the sake of regulation, if we increase the number of board of independent directors in the board, that may not suffice our purpose. Let me give you a simple example. I'm sure all of you can recall. Though it is not a bank, but I'm giving you the example of Sattam, IT companies. Sattam was the fourth largest cash-rich IT company in India. I still can recall the day when promoter and CEO of Sattam, Mr. Ramalingam Raju, admitted in the public domain that we are manipulating the balance sheet for last couple of years. We have done the creative accounting. We have done the window dressing. Believe me, in the same day, from 400 rupees, stock price has come down to 8 rupees. So, in Sattam, that time, there were 9 directors in the board. Out of them, 6 were independent directors. That means Sattam's decision to acquire its own subsidiary at a huge valuation, this decision was approved by independent directors. So thereafter, SEBI has also given the verdict that independent directors somehow have failed to deliver because they are not utilizing independence of their mind and brain unless and until they're able to apply their independence of body and brain, it will not suffice. Now see corporate governance disclosure index and average net NPA, minus 0.586. It is quite clear. If the bank's non-performing asset is increasing, that means somehow credit scoring models, credit appraisal systems of the banks are not doing good. That means credit appraisal committee is unable to do justice. So, net non-performing asset and corporate governance performance, they are inversely related. But yeah, if banks are maintaining higher capital adequacy ratio, which is requirement of Basel 1, Basel 2, Basel 3, you know better. As per the revised norm of Basel 3, all banks have to maintain at least 10.5% capital adequacy ratio. And since the Reserve Bank of India, the apex body of Indian banks, they are following the conservative path. So they have instructed all the banks to maintain at least 11.5% capital adequacy ratio. And out of that 11.5% capital adequacy ratio, at least 9.5% should be in terms of Tier 1 capital. Tier 1 capital means ownership capital, that is equity capital and reserve and surplus. And remaining maybe Tier 2 capital. So, here if you see, corporate governance disclosure index and the capital adequacy ratio correlation coefficient is 0.647 positive. That means higher the capital adequacy ratio bank is maintaining, higher the tier 1 capital adequacy ratio bank is maintaining, it shows prudent corporate governance. Average return on equity and corporate governance disclosure index, it also shows positive correlation. That means, what is return on equity? Return on equity, if it is more, that means bank is able to give adequate return to its shareholders. So that means company's corporate, unless and until company's corporate governance is not sound, bank cannot give the justice to the shareholders. Otherwise, what will happen? There will be scam like PNB. There will be scam like Yes Bank. There will be issue like Chanda Kochar, which happened in ICICI Bank. Members of internal audit committee. Again, if you see corporate governance disclosure index and internal audit committee, correlation is significant, but it is negatively correlated. That means more number of audit committee member cannot suffice the purpose unless and until they are applying their full personal and professional integrity. So, my study has observed that small is beautiful. Because when your board size is small, when your independent director is small, when your audit committee size is small, then it is easier to utilize the capability of the board, capability of the audit committee. But when the board size is big, when there are more members in the audit committee size, sometimes it happens, there is a lack of coordination. In the theory of economics, we are talking about these economies of scale. When company becomes large, obviously these economies of scale, when we are talking about, there is the economies of scale also. So economies of scale is saying when we are producing in bulk, my average cost of production will come down. So if I go for scalability, if I go for bulk production, bulk purchase, I will receive discount in cost. But if my size becomes too big, then as an entrepreneur, as a promoter, I cannot control all the affairs. Whether it is production, whether it is purchase, whether it is marketing, whether it is finance, whether it is HR. So I have to delegate the authorities. And once I have to delegate the authorities, by default, managerial experience will go up. So these diseconomies of scale actually is being reflected. Once we are saying corporate governance disclosure index is inversely related with average independent directors and average internal audit committee. And it is also inversely related with average number of board meetings. That means if you conduct 14 to 16 board meetings, but if you discuss only the routine items, if you cannot provide the necessary ambience where qualitative discussion should be more, where board members can raise their concern. So for the sake of conducting the meeting will not suffice the purpose. Then I have conducted multiple regressions by taking corporate governance disclosure index as the dependent variable and all the variables which are significant as per the Pearson correlation. Just look, the variables which are insignificant. Which are the variables are insignificant? That is average income and average both side and average earning per share. These three variables have been removed. So here in dependent variable is corporate governance disclosure index, Independent variable is local ownership, independent directors in the board, return on asset, net NPA, capital adequacy ratio, return on equity, member of internal audit committee, number of board meetings. Now, if you see here, there are significant level. Almost all the variables are insignificant in nature, because if you see, significant levels are much more than 0.05. So gradually I have to drop the insignificant variable. So now you tell me which one is the highest insignificant. If you see, highest insignificant variable is what is it? So highest insignificant variable is return on equity, 0.651. So gradually I started to eliminate the insignificant variables. And then my final models come to corporate governance disclosure index is equal to C plus beta 1 ROA. My adjusted R square, it is 55.8. So ROA is the significant, and final model is corporate governance disclosure index is equal to 89.853 plus 3.933 ROA. That means if return on asset is increasing, there will be almost 4 times hike in corporate governance disclosure index. That means higher the return on asset, corporate governance practice is more sound. Now, second part of my study, relationship between corporate governance practices and financial performance of the banks. Whether banks which are following sound corporate governance practices, are they having good financial performance, and vice versa? So bank performance we have measured on the basis of earning per share, return on asset, and return on equity. And corporate governance practices, we have taken board size, board independence, average internal audit committee size, average capital adequacy ratio, and average number of board meetings. So here, this time if you see return on asset, EPS, and return on equity, you have taken as dependent variable, and independent variable is board size, independent directors, capital adequacy ratio, members of internal audit committee, and board meeting. Now, by taking return on asset as the dependent variable and board size, independent directors, capital adequacy ratio, audit committee size, and board meeting as the independent variables, when you have conducted the Pearson correlation coefficient, because this data follows normal distribution, so parametric test we can conduct. So if you see average return on asset and average independent directors, they are inversely related, and it is significant because p-value is less than 0.05. Average return on asset and capital adequacy ratio significant, p-value is less than 0.01. Average return on asset and average audit committee size -848. So p-value is less than 0.01. And average return on asset and average number of board meeting. So p-value is less than 0.01. Am I right? So correlation coefficient between return on asset and number of independent directors in the board, return on asset and capital adequacy ratio, return on asset and audit committee size, return on asset and number of board meetings are significant. But correlation between return on asset and board size is insignificant. So I have conducted multiple regression taking return on asset as dependent variable, board size, independent directors, capital adequacy ratio, member of internal audit committee, board meeting as independent variables. Now adjusted R square, if you see it is 90.5%, but few variables are insignificant. So my highest insignificant variable, if you see capital adequacy ratio, its significant level is 0.206, much higher than 0.05. So gradually I have started to remove the insignificant variables. So my final models comes down to return on asset is equal to C plus beta 1 member of internal audit committee, beta 2 number of board meetings. If you see adjusted R square is 84.9%. And if you look, both the cases, they are significant because p values are less than 0.05. Now question will come, what is the proof that variables don't have the multi-collinearity? Please try to understand, when we are conducting the multiple regression, that means we are trying to analyze the relationship between dependent variable and multiple independent variables. We have to also check that multiple regression cannot give you the result unless and until independent variables themselves are not connected. If they are connected itself, suppose, let me give you the example. Suppose I want to analyze what is the impact on crop production. So crop production I'm taking as dependent variable, and independent variables I'm taking, say, temperature, I'm taking the humidity, I'm taking the average rainfall, I'm taking the pesticides used, I'm taking the fertilizer used. So how this temperature, humidity, rainfall, pesticide, fertilizers, irrigation facilities are affecting the crop production. Then I will conduct multiple regression taking the dependent variable as crop production and independent variables as this temperature, rainfall, humidity, irrigational facility, fertilizers and pesticides. But if these independent variables are itself related with each other, if there is itself relationship between temperature, humidity, rainfall, fertilizer, pesticides and irrigational facilities, then there will be multicollinearity. So that's why we have chosen VIA, variance inflation factor. If variance inflation factor is less than 3, actually in research we can take less than 5, but in industry it is less than 3, then multicollinearity is no longer there. So the model is foolproof. So ROA is equal to 3.071 minus 0.17 MOAC, that is member of internal audit committee, minus 0.102 number of board meeting. Now, next is that when I'm taking EPS as the dependent variables and board size, independent director, capital adequacy ratio, audit committee size and number of board meeting as independent variables, you will look here, correlation coefficient between EPS and board size, EPS and number of independent directors, EPS and number of audit committee are significant. Look, EPS and board size, p-value is 0.025.
Sir,
Yeah.
hello, sir. Just to interrupt,
Yeah.
there are 5 minutes left. Okay. See you.
Thank you.
Okay, no problem.
Yeah, I'll conclude within 5 minutes.
Okay, thank you.
So, if you look, that only these 3 variables are significant. Now, once we are conducting the multiple regression, if you see, adjusted R square is abysmally low, 7.3%. So this model does not fit. So I dropped the model. Next model I have taken, average ROE as the dependent variable and average board size, average number of independent directors, average capital adequacy ratio, average audit committee size, and average board meeting as the independent variable. If you see here, ROE and capital adequacy ratio, they are significant. And ROE and number of board meetings, they are significant. So again, I have conducted multiple regression taking ROE as the dependent variable and board of directors, independent directors, capital adequacy ratio, member of internal audit committee, and board meetings as the independent variables. Now adjusted R square is 46.4%. Again, if you see, few variables which are really insignificant. Significant value is very high, 0.916. So I have to drop the insignificant variable. After dropping the insignificant variable, my final model is ROE is equal to C plus beta 1 BOM plus E. Adjusted R square is 67.6%. So final model is ROE is equal to 24.76 minus 1.094 board meeting. So if you see that the hypothesis 1 has been tested by Mann-Whitney test, hypothesis 2 has been conducted by Kruskal-Wallis test, hypothesis 1 it has been accepted, hypothesis 2, in hypothesis 1 alternative hypothesis has been accepted. So corporate governance practices of public sector and private banks vary. But in hypothesis 2, Kruskal-Wallis test, null hypothesis is accepted. Corporate governance practices of public sector banks and private banks do not vary. Now for rest of the hypothesis, Pearson correlation coefficient and multiple regression has been used. Hypothesis 3, null hypothesis is accepted. There is no relationship between corporate governance disclosure index and average income. Hypothesis 4, alternative hypothesis is accepted. There is inverse relationship between corporate governance disclosure index and average local ownership, and correlation coefficient is minus 0.633. For hypothesis 5, null hypothesis is accepted. There is no relationship between corporate governance disclosure index and average board size. Hypothesis 6, alternative hypothesis is accepted. There is inverse relationship between corporate governance disclosure index and average board independence, and correlation coefficient is minus 0.676. Hypothesis 7, alternative hypothesis is accepted. There is a strong positive relationship between corporate governance disclosure index and average return on asset. If you see, correlation coefficient is 0.773, and according to multiple regression, relationship between corporate governance disclosure index and average return on asset is significant. Hypothesis 8, alternative hypothesis is accepted. There is inverse relationship between corporate governance disclosure index and net NPA. It is minus 0.586. Hypothesis 9, alternative hypothesis is accepted. There is direct relationship between corporate governance disclosure index and average capital adequacy ratio, 0.647. Hypothesis 10, alternative hypothesis is accepted. So there is a direct relationship between corporate governance disclosure index and average ROE. Correlation coefficient is 0.582. Hypothesis 11, alternative hypothesis is accepted. There is an inverse relationship between corporate governance disclosure index and average audit committee size, and correlation coefficient is minus 0.619. Hypothesis 12, null hypothesis is accepted. There is no relationship between corporate governance disclosure index and average EPS. Hypothesis 13, alternative hypothesis is accepted. There is inverse relationship between corporate governance disclosure index and average number of board meeting. So it is minus 5.581. Hypothesis 14, null hypothesis is accepted. There is no relationship between bank performance and average board size. Hypothesis 15, alternative hypothesis is accepted. There is inverse relationship between bank performance and average board independence. Correlation coefficient is 0.599 between ROA and board independence. Hypothesis 16, alternative hypothesis is accepted. There is a strong inverse relationship between bank performance and internal audit committee size. If you see return on asset and average internal audit committee size, it is minus 0.848, and according to multiple regression also, the relationship between ROA and average size of internal audit committee is significant. Now, hypothesis 17, alternative hypothesis is accepted. There is strong positive relationship between bank performance and capital adequacy ratio. Correlation coefficient between average ROA and average capital adequacy ratio is 0.899, and average ROE and average capital adequacy ratio is 0.68. Last but not the least, for hypothesis 18, alternative hypothesis is accepted. There is strong inverse relationship between bank performance and average number of board meeting. Correlation coefficient between average ROA and board meeting, it is minus 0.898. Average ROE in average board meeting is minus 0.822. And according to multiple regressions, relationship between average return on asset and average number of board meetings is significant. Similarly, the relationship between average ROE and average number of board meeting is also significant. So this is my study. Sorry for exceeding 2 minutes. Now tell me, anybody has any question? This is my research work and my presentation on normality test and impact of normality test on data analysis.
Thank you so much, sir. I think we are, over the time, and I would request if anybody has any questions, then they can post it in the WhatsApp group. Because of scarcity of time, I think we'll not be able to take the questions right now. And I thank you so much, sir, for such a wonderful session and discussing your thesis, findings, and giving us an enlightened idea about how to go ahead with the normality test. And we are truly, honored getting such great insights from you. I would request Obijit, sir, to take over the session and close the session. Thank you so much, sir. And thank you, Shujoy, sir, again.
Thank you so much, madam. Thank you so much. And thank you all the participants for your patience hearings.
So with this, we come to the conclusion of today's session. So we have one question. So due to paucity of time, we couldn't take it. So we will send this question to Sujoy sir. And with this, we come to the end of day 4 of this workshop. And I think you enjoyed both the sessions. And both the session was very fruitful, I hope. And we are again going to meet tomorrow sharp at 7 p.m. Till then, good night. Have a nice time. So thank you all.
Thank you,
Good
sir.
night, sir. And good night, everybody else.
Thank you. Thank you.
Ronak, are you there?
হ্যাঁ রৌনক আছে মনে হয় হ্যাঁ
ও আচ্ছা, তাহলে লিভ করে যাচ্ছি আমি, হ্যাঁ।